In this PowerPoint talk, I'm not going to try to validate free energy. I've already done that quite extensively, both on Quora. I've done extensive blogging, my 2,000 books self-published on Amazon, my website, vinyasi.info, where else? My draft copy of Free Energy Does Not Exist over at Wikiversity, and my paper that I presented to this conference. So I want to skip ahead away from that, that need that we might feel to justify free energy. I don't feel the need to go there anymore. I want to simply tell you in this PowerPoint what are the overview of what are the basics of creating an Overunity circuit, a circuit that creates more energy coming out of it than what we give it. And it's really quite simple, and it's not much to say in 30 minutes time. It's more like 2 minutes time. So microcap has helped me now understand that reversal of time does not need to occur, nor does it occur all of the time. So a circuit does not have to create overunity all of the time to be overunity all of the time. It only has to synthesize electricity momentarily for little spurts, and usually in the beginning, because that's usually the way transient surges happen anyway. So all that is needed to design an overunity circuit is the ability to retain reactive power. You want it to build up, and you want it to build up at a rate which is faster than the rate at which you will be spending and or losing real power. So obviously some of that reactive power is going to convert into real power prior to its loss as real power. But as reactive power, you can't lose it. By definition, reactive power is not power. It's in the realm of the square root of -1, so not only can it not be measured directly, but it can't even be lost. But it's still there, and it still builds up, and we know by experience over the past century that that's what it's like, a working knowledge that we have, that without any proof, it's there, and it has to be accounted for with mathematics, and which is pretty accurate. So we want the reactive power to build up at a rate that's faster than it converts into real and gets lost and spent. And it's like filling a leaky bucket with holes in it, but we're not filling it. We do initiate a certain amount of real power that we inject into the situation, but that's it. And then under those conditions of starvation, we want the reactive power to build up. So the retention of reactive power is going to be done in two parts of the circuit, or two types of areas of the circuit. They may not just be two areas, but there are two types of areas. One area is an open transmission line that will build up the voltage. The other area will be connected to one or the other or both terminal ends of that open transmission line as a self-looping condition, a self-looping short, a self-shorted loop, to retain current as best it can by not allowing it to go anywhere. We don't want it to go through a load, at least in this retention area. We can magnetically couple it to a load, but that load will be electrically separate from this retention area, because this is connected to the voltage buildup section. And so this is a dielectrical or electrostatic buildup, but we have to cover both ends. We have to cover the buildup of magnetism, i.e. current, as well as the buildup of strictly voltage alone. That's why if I have a voltage source that I'm feeding into the circuit from outside the circuit, I'll only feed it one terminal. The other terminal of the voltage source goes to ground. I want the current to get thrown away when I input a voltage source into a circuit, because by definition a voltage source should be giving my circuit just that and nothing else. You know, it's kind of silly to have a battery pack in a car that's your source of voltage, but also your source of current, because it keeps depleting the level of voltage in your battery pack in the course of doing that. So we have to segregate our circuit's needs into its two distinct areas of voltage and current, and yet both have to build up in some retentive fashion, and then we can magnetically couple the magnetic or the current area of buildup to a load. And the load could be a self-short because it doesn't go to a power source and it should not go to the retention area. So things have to be isolated in a very intelligent way, so that on the one hand we build up voltage and current and keep it separate from where we spend the current. So the retention area that builds up voltage and current is a kind of derivative of the Ankh, the Egyptian symbol for life, except I take away the cross piece and turn it on its side, so it's easier for me to think about it in a thematic manner. And so it's basically just an open transmission line. At one end of that open transmission line, it shorts to itself and creates a loop. Thematically, in terms of a block diagram, that's all we need to say in describing what we need. As to what the circuit will actually be when you design it, it's going to be far more complicated. But this is just to get the concept across. Now, the other thing we need is to periodically inject spurts of transient surges of time reversal into the situation. But it doesn't have to be often, and it doesn't have to be throughout the time frame of the circuit running itself. It only need be in the beginning, and we know from experience that when we open and close a switch, that creates a surge. So a few of that, and we're good to go, because a mechanical switch is two contacts that are the two plates of a capacitor, and it has a dielectrical medium in between those two contact points of the air, and it's parametric because we're changing the capacitance, because we're changing the distance between those two contacts as we open and close the switch. And then if we get it close enough, we might get arcing, probably ionization, and now we've got negative current or reversal of current, which is time reversal happening for a little bit. So it's really not that hard to create a spurt of a transient surge that is the reversal of time, because it's the reversal of current. It's not that hard, and it doesn't have to happen often, and it can happen in the beginning and just maybe periodically over the course of running the circuit to remind it to keep its reactive power up at a nice level. So it's like a booster shot, you know, just once in a while we give it a little booster shot, but most of the time we have to retain what we've injected so we don't lose it. And that's the design that I've described to you, an open transmission line and a self-looping short at least one end of that line. Now, to further modify the operation of the circuit, it's good to make use of the factors of reactance. And as far as I know, there's only four to deal with: frequency, self-inductance, self-capacitance, and magnetic coupling, which is a cover term for a simultaneity of two things happening at the same time, involving mutual capacitance and mutual inductance, but they have inverse relations to each other. So that when we have a strong magnetic coupling, let's say 90% between two or more coils, we're going to have also a very high mutual inductance, but we are also going to have, conversely, a very low mutual capacitance. Conversely, if we have a weak magnetic coupling of 0.01, 1%, then the mutual inductance is going to be very low, obviously, but there's also going to be mutual capacitance, which is now elevated by contrast to a 90% magnetic coupling. And this is something I think we overlook, because I haven't run across it anywhere, but I've learned about it from all the different experiments that I've done under simulation. It's kind of inferred knowledge. After a while, you get kind of a sense that, you know what, I see capacitance lurking about in there, but I don't have it in the form of self-capacitance. Where is it coming from? And then when I think it through logistically or thematically or simulated in my brain, what is actually mutual inductance? What does it really amount to? It amounts to the inverse of mutual capacitance. So they're really one and the same thing, but for the point of pragmatism, we'll just call it magnetic coupling, because that's how I access this mutual capacitance. I don't know any other way to do it, quite frankly. If there is another way, you can tell me, or I'll just bump into it on my own, but at least I can access it now that I know that I can access it indirectly through magnetic coupling, through a very low mutual inductance. And that's it. That's the bottom line and the overview and the broad view, the first and the last word on the subject of how to create overunity, how to create free energy, because we're not creating energy, right? According to my submission to this conference, we're just changing perspective, but from the point of view of the energy, not from our point of view. Our point of view doesn't count. I mean, we can look, we can witness what's happening, but we have to be careful not to judge what's happening from our point of view. We always have to take the point of view of the energy inside of our circuit in order never to create errors of judgment of what's happening. Oh, there's violation of conservation of energy. No, I don't think so, because the time, from our point of view, the time for the energy in the circuit has gone backwards in creating the reversal of current. And yet, from the point of view of the energy inside the circuit, nothing happened whatsoever along those lines. Time did not reverse. It's still going forward, and it's damping. As far as it knows, it doesn't know the difference. Only we know the difference, because it looks like it's doing the inverse of damping, negative damping. But that's not from the point of view of the energy. So you see, if we want to believe in conservation of energy, fine. Just so long as we realize we have to give up something in the course of believing so steadfastly in conservation of energy, which there's nothing wrong with it if you want to, but we have to give up this silly notion that time remains the same for a single observer over the course of running a circuit that is exhibiting overunity.